Okay, so this video is going to be over freefall 2B, which is basically over projectile motion. We talked a little bit about projectile motion in the last video. So remember that an object in freefall is falling only under the effects of gravity. And a projectile is basically an object that is in freefall, but it's also moving sideways. Okay, so projectile motion is the motion of an object falling in 2 dimensions. So in this section, you're going to take notes, of course. You do have a simulation lab to work on over projectile motion, and then you'll have a practice assignment and a quiz. So just to review, a projectile is an object that is launched into the air and is acted upon only by gravity. So these are not things that have an engine. So a helicopter or an airplane or a bird flapping its wings, those are not projectiles. A projectile is only under the effects of gravity. When you throw, or not throw, when you have a projectile, for example, when you throw a baseball, or when you shoot a basket in basketball, the trajectory is what you call the path that the projectile takes as it flies through the air. And as you'll see in your simulation lab, the path of a projectile as it flies through the air is a parabola. It's what we call a parabolic path. Okay, so that is the trajectory of an object in projectile motion. And we talked before about some examples of projectile motion. So that would be, a baseball flying through the air, a basketball, when you shoot a basket. If you take a gun and you fire a bullet, the bullet as it flies through the air is still falling, it's still in free fall, and so that is an example of a projectile. When a car drives off a cliff, that is an example of projectile motion. And there's lots of examples of projectile motion, especially pertaining to things like sports. So, here's some things you need to know about projectile motion. Now, in the last video, we talked about normal freefall problems. And in a freefall problem, you're basically dealing with an object with constant acceleration that is just moving up or down. In a projectile motion problem, I'm trying to adjust this so you can see it better. In a projectile motion problem, you actually have two things going on at the same time. Number one, the object is falling because it's projectile motion, but number two, it's also moving side to side. And so, in other words, there's two things happening at the same time. You have horizontal motion side to side, and you have vertical motion up and down. Okay, that means we're going to have basically two equations dealing with projectile motion problems, and we'll talk about that in a couple minutes. But basically, what we're going to have is we're going to have constant velocity, which was the first thing we talked about in this course, and constant acceleration at the same time. We're going to have constant velocity in the x direction, in the horizontal motion, and we have constant acceleration because we have acceleration due to gravity in the y direction as the object is falling. Okay, so we're basically going to have to combine everything we've talked about up to this point. Now, before we solve any problems, take a look at this question. This question says a pistol shoots a bullet horizontally at the same time that a second identical bullet is dropped from the same height as the pistol. And you can kind of see in this picture here. True or false? The bullet that is shot forward is going to hit the ground before the bullet that is dropped. Again, keeping in mind that the bullet is dropped at the same time that the bullet is shot, and the pistol is perfectly horizontal. Okay, so true or false? The bullet that is shot forward will hit the ground before the bullet that is dropped. Okay, so the answer to the question is actually false. They're actually going to hit the ground at the same time. And normally I would show you these videos in class. I will link them so that you can check out the videos on your own. But basically, the bullet that's shot is shot horizontally, but that horizontal motion does not affect the time it takes to fall, because falling has to do with vertical motion. That's an up and down thing. Okay, that's not a side to side thing. Okay, so just because a bullet is shot, as long as it's shot perfectly level, perfectly horizontal, it's not going to hit the ground any faster than the bullet that's dropped. Okay, so check out those two videos. But that's basically the idea that the horizontal motion and the vertical motion are both completely independent of each other. Now, I said before you have a simulation lab. Okay, so just read and follow the directions as you complete that after you watch this video. And we'll get to solving problems in just a second. I think most of this I've already covered. With projectile motion, you have two types of motion at the same time: horizontal, that means side to side in the x direction, and vertical, up and down, where you have free fall, constant acceleration, and those two types of motions are independent of each other. Okay, that means it doesn't matter how fast you throw something or how fast you shoot something, as long as it's from the same height, and as long as it's thrown or shot completely horizontal, they're going to land at the same time. Now, of course, if you point your gun, at the ground and shoot, it's going to hit the ground faster, obviously. But the time for the projectile to reach the ground depends only on the height that the projectile is launched with, because the horizontal velocity is completely independent of the vertical motion. We talked about the shape of a projectile's trajectory. That is a parabola. Hopefully you also see that in your simulation. This is getting kind of repetitive because there's nothing new on this slide either. But basically, this kind of breaks down the two types of motion that you have with a projectile. You have the horizontal motion, which is constant velocity. And the reason you have constant velocity in the horizontal motion in the x direction with a projectile is because we're talking about free fall, which means we're talking about acceleration due to gravity. Well, gravity acts straight down. Okay, gravity doesn't act side to side. And so that means if you shoot a bullet, gravity is going to pull the bullet down, but it's not going to pull the bullet side to side. And so that means we'll talk about forces later, but that means there's no forces, there's nothing pushing or pulling the bullet side to side. And so as far as the horizontal motion is concerned, it's just going to keep moving at the same velocity. But because gravity is pulling the bullet down, it's actually going to accelerate and increase the velocity down of the bullet. Okay, so you have constant acceleration and you have constant velocity, okay, both at the same time. Okay, if you look at these arrows basically represent the two different velocities. You can see this is basically a ball flying through the air in projectile motion. You should notice that the horizontal velocity is constant because the arrows are the same length, whereas the vertical velocity, it starts off pretty high and then it decreases. At the maximum height, the vertical velocity goes to 0. We've talked about that before. And then it starts to fall back down again. Okay, and so there's two different things going on at the same time with projectile motion. Now, because there's two different things going on, there's two different equations we're going to use to solve problems with projectile motion. So here are the two equations that we're going to use to solve projectile motion problems. We have one with dx, and we have one with dy. Now, the dx equation is the constant velocity equation. In fact, if you look at it, d equals v times t, that's the very first equation we saw in this course. That is the constant velocity equation. The x's are there just to tell us that is the x equation, that dx is the displacement of the projectile in the x direction, in the horizontal direction, and then dy is the up and down displacement. Okay. This equation should look somewhat familiar, the 1/2 gt squared. That's very similar to an equation we've seen before. Remember that g is the acceleration due to gravity. That we use a value of -10 meters per second squared for that. And so basically, to solve projectile motion problems, you're going to have to combine these two equations. Okay, so make sure you get those down. I'll make them a little bit bigger so they're easier to see. Okay, so let's do some examples with projectile motion. Sorry for the formatting on this slide. That red line is kind of annoying. Okay, so let's try this. So the question says, a car rolls off a cliff at 30 meters per second and hits the ground 3.5 seconds later. Now, before we start writing things down, I do want to point out something. Between these two projectile motion equations, there is only one velocity in either of these equations. Okay, and that is Vx. Okay, that is the horizontal velocity of the projectile. Okay, so just keep that in mind. So as I'm going through, the car rolls off a cliff at 30 meters per second. The first thing I'm going to say is this must be Vx. This is the velocity because it's meters per second, and that's how fast the car is moving horizontally in the x direction before it rolls off the cliff. By the way, if you want to know how would you even recognize this as a projectile motion problem, well, if you okay, I can't draw. Let me try this again. If you were to draw a picture of the situation, and this is a car, and it drives off a cliff, it's going to go something like this. And this shape of this path is a parabola like we talked about before. So this is a projectile motion problem because the car is moving sideways, but it's also falling down at the same time. Okay, now, so we have Vx, and it hits the ground 3.5 seconds later. Now, of course, seconds is time, so I'm going to label that as t. Now, the first question says, how tall is the cliff? How tall? So remember, we have two equations. We have dx equals vx times t. Okay, that's our x equation. And we have dy equals 1/2 gt squared. Okay, so you have two different displacements, and you have to use context clues to figure out which one is which. Now, a question about how tall, think tall means height, right? That's up and down. So how tall is the cliff is a question about height. That means that's a question about dy. That is going to be our unknown. So I'm going to use the equation for dy. I'm going to write that equation down, and I'm going to plug in. G, remember the acceleration to gravity is -10. And then t squared, t is 3.5 seconds. We found that before. And so I'm just going to type that into my calculator. By the way, as I type this out, do be aware that projectile motion questions like this very often are multi-step problems. In other words, you typically have to find one thing in order to find the next thing. Now, that's not the case here, but a lot of the time it is. Okay, so don't be surprised if you have like a part A and a part B and a part C, and you have to use your answer from part A to figure out the answer to part B, and so on. Okay, now this is actually -61.3 meters. That is the displacement. Now, the question, how tall is the cliff? Remember, you can't have negative height. So the actual answer to the question is 61.3 meters. Okay, and so that would be the answer to the question. dy is negative because the car fell down. It moved in the down direction. But of course, you can't have a negative height. Now, the next question says, how far from the cliff's base did the car land? So there's two types of displacement. And if you look at this picture, dy is basically from the top of the cliff to the bottom of the cliff. So this is dy. dx, and again, I apologize for this picture. It's a very bad picture, but it's the best I can do. This is dx. Dx is how far the car moves in the x direction, in the horizontal direction. Now this, how far from the cliff's base of the car land, this dx has a name. Okay, dx is called range. So if you ever get a question asking you to calculate the range is dx always. Okay, so we want to find dx. Now at this point it's very easy because look, there's only one equation that has dx in it. Right. I have Vx, that's given, that's 30. I multiply it by t, which is 3.5. And I type that to my calculator. Okay, and I get 105 meters, and I'm done with the question. Okay, so that is example 1. That is a projectile motion question. Okay, we're going to do one or two more examples. Okay, pause it here if you need to. Okay, so take a look at example 2. Okay, so example 2, another projectile motion question, of course, and it says a ball is launched horizontally from a 100-meter high cliff at 20 meters per second. We got a little picture here to help us understand. Remember that shape of this path is a parabola. We talked about that before. Okay, so the first question says, how long does it take the rock to land? Okay, now if you look at what we're given the height of the cliff. It's a 100-meter high cliff. Okay, that's going to be our dy because remember height is up and down, and so that's a y displacement. 20 meters per second. Look at the units, meters per second. That has to be velocity, so that has to be Vx. So the question says how long, and how long is always a question about time. Now the trick here is there's actually two equations that have time. Okay, so you might ask yourself, how do I know which equation to use? Well, one way to figure that out is to, try both of them. If you look at the first equation, notice that we have Vx, we don't have t, but we also don't have dx. And so we don't actually have enough information to use our dx equation. That means we have to use the dy equation to find time. Okay, so I'm going to use my dy equation. That's 1/2 gt squared. I'm going to plug in dy. Guess what I'm going to put for dy? It's not going to be 100. It's actually going to be negative 100 because the ball is going to go down by that amount. Okay, remember the direction is indicated by the negative sign. So we have negative 100 equals 1/2. Remember g is negative 10. And then we have t squared. Now here I need to simplify and do a little algebra and rearrange and get t by itself. So negative 100 equals half of negative 10 is negative 5 t squared. I want t by itself, so I say what's being done to t. It's being multiplied and it's being squared. I want to do PEMDAS backwards to get t by itself. And so the first thing I'm going to do is I'm going to divide both sides by negative 5. Okay, negative 100 divided by negative 5 is 20. That is equal to t squared. And then I need to undo the square because I don't want t squared, I want t. And so I need to take the square root of both sides. And I'm just going to do that into my calculator. I'm going to do the square root of 20. Okay, so the square root of 20 is approximately 4.47. And I'm going to write seconds for seconds. Normally I would write an S for seconds, but it's hard to tell with my handwriting if it's a 5 or an S. So 4.47 seconds. Or you could say 4.5 seconds, and that would be fine. Okay, so we're halfway done with example 2. We just found the time it takes the rock to land. Now, we have horizontal motion with our x equation, and we have vertical motion with our y equation. Now, they're completely independent of each other, except that they have time in common. That means once we find time in one equation, we can use that same time in the other equation. Okay, so keep that in mind. Pause it here, write all this down, look over it, check your answer on your own, but especially keep this answer in mind. This 4.47 seconds, we're going to use that to finish the question. Okay, so I'm going to erase this. Okay, so 4.47 seconds. The next question says, what is the range of the ball? And remember, range is the same thing as dx. It's basically saying, from here to here, what is this horizontal distance that the ball traveled? This is the range. This is dx. There's only one equation for dx. Okay, and now this is very simple to do because we have Vx, we found that before, that's 20 meters per second. And now we have t, that's 4.47 seconds. That's the parentheses. It's hard to tell, but that is parentheses. So if you multiply those two, you should get 89.4 meters, and that's going to be our range. That's going to be dx, and that is the answer to example 2, part B. Okay, so pause it there if you need to take a look at that. Okay, so just really quickly, I want to take a look. I don't know if I want to do this calculation again. This is another problem you can work on your own. See if you can get these two answers. But I do want you to take a look at this question right here. Okay, so it says a rifle bullet is fired horizontally from a height of 1.6 meters. The rifle bullet lands 487 meters away. The first question says, how does the horizontal velocity of the bullet change after it's shot? So this is a concept question. Okay, the concept, remember, in the horizontal motion, you have constant velocity, because the only thing causing any acceleration is gravity, and gravity acts down. Okay, so the horizontal velocity of the bullet is not going to change. It's going to remain constant after it's shot. The vertical velocity of the bullet is going to change. right? Because acceleration to gravity means the bullet is accelerating down because of gravity, and so the vertical velocity is going to change. It's going to decrease because it's going to change by negative 10 meters per second each second. The acceleration of the bullet is also not going to change. It's also going to stay constant. So this one and this one are both going to remain constant because the bullet is in free fall. You have constant acceleration due to gravity, so the acceleration is not going to change. And then the last question, what is one way to increase the time it takes for the bullet to hit the ground? You can increase the height. That's probably the most straightforward way to increase the time for the bullet to hit the ground. Because if you increase the height, it's going to take a longer time to reach the ground. Okay, so that's how you would answer some of these more conceptual questions. Again, there is a calculation question on here that I don't want to do because of time, but if you want some extra practice, see if you can do these ones on your own. As always, please let me know if you have any questions, and I will see you guys in the next video.